hint for 12?
For 12? Okay, sure. 12. It says let n equals this how many factors of n squared or less than n, but don't divide n. Okay. How many factors of n squared? So can you tell me n squared is what?
2 raised to 46, 3 raised to 34.
It says don't divide n. So suppose a good factor, for example, 2 to the alpha, 3 to the beta, right?
Mhm.
What can we conclude when it says don't divide n?
Alpha is greater than 23 or beta is greater than 17.
In this case, when alpha is greater than or equal to 24, what can we say about beta?
Beta less than 17.
Yes, less than or equal to 16. Why?
Because otherwise it'll be greater than n.
Exactly, because of this condition. Second condition, second case is alpha what? Less than or equal?
22.
And beta greater than or equal? Beta greater than or equal what?
18.
Okay, let's calculate one case. For example, 2 to the 24. 2 to the 24. Here we know this condition is easy. This condition is satisfied. We should only focus on this condition, right?
Right.
So 2 to the alpha, 3 to the beta here should be less than 2 to the 23 times 3 to the 17, right?
Right.
Okay, one way if we use a small example, for example, 24, it will be what?
It'll be
Okay, if it is 24, can you tell me? 3 can be what?
3 can be 3 can be 16. 1
3.
0.
When it is,
No.
let's write this. For example, 3 to the beta is 2 to the 23 times 3 to the 17, right? So it is equivalent to what? 2 times 3 to the beta should be less than 3 to the 17, right?
Right.
So beta can be what? From what to what?
0 to 16.
Yeah, so how many cases?
17.
It is for the case that 1, 1. Alpha is 24, right? 1, 2. If alpha is 25, we can say what? 2 times 3 beta is less than 3 to the 17, right? 2 squared. So
Right.
beta here can be from what to what?
15.
Yes, you can also say that 2 squared is less than 3 to the 17 minus beta, right? So you should find first power of 3 that is greater than this, right?
Right.
So your question is what? You have a question?
Oh, no.
Okay. So 2 cubed for next case less than 3 to the 17 minus beta, right?
Right.
So beta can be what to what?
0 to 15.
Yes. So here you should check beta and you can see, for example, up to which part. When it is 8 from 9, it will be okay. So it will be this. For next one, 2 to the 4, it will be what?
14. So 15 to
15. So like here, you can find all cases for this, right?
Okay.
One more hint or that's enough?
That's enough.
Okay, sure, try. Want hint or wanna keep trying?
Wait, do you just keep listing from 24 to 36 to 46?
24 to 46. Yes. Have you checked that?
Oh, no, not finished yet.
Okay, so if you write for first one for 2, because we know, suppose 2 to the alpha minus 23 is less than 3 to the 17 minus beta, right?
Mm-hmm.
Alpha minus 23 can be from what to what?
From 1 to 23?
Exact, from 1 to 23. What about 17 minus beta?
From 1 to 17.
Mm, yes, so do you agree we can say 2 to the, instead of alpha minus beta, we can say x is less than
Oh, so you're
equal
just
3
getting
to the y,
numbers.
right? And x is from 1 to 23. Y is from what to what? 1 to 17, right? So here you say, okay, for 2 to the 1. So when you consider 2 to the 1, 2 squared, 2 cubed, you can see. And also here we have what? 3 to the 1, 3 squared, 3 cubed, to 3 to the 17, right?
Mm-hmm.
Okay, so for 2 to the 1, let's write something like this. For 2 to the 1, how many of them are greater than that? Here, let's see. It's a 17, yes. 2 to the 1, how many of them? 17, right? For
Right.
2 squared, it is what? From here, right? 16.
Okay.
For 2 cubed, from here again, 16. Do you agree if we write like this, we can quickly calculate? 2 to the
Okay, yeah.
4, it will
So
be from 3 to the 3, 3 to the 4, 3 to the 5. So 2 to the 4 from what is what?
15.
Yes, because it will be from here, from 3 cubed, right?
Mm-hmm.
2 to the 5 is what?
2 to the 5 is 3d2 is great. 14.
14 from here. For 2 to the 6, again
14.
14. For 2 to the 7, it
It's
is
13.
13, because it is, let's update this. From 3 to the 5, right?
Right.
3 to the 5 is what?
Um,
243, right?
12.
So
Yeah.
it's 12. And you can calculate like this to reach 2 to the 23. Want to try rest on your own?
Yeah.
Okay. And also for other case, you should do similar thing, okay?
Um,
So try. Want hint or want to keep trying?
I'll keep trying.
Okay, sure. I think it's a bit long for calculation, right?
Alright.
If you think it's hard, we can also pay attention to Gauss idea. Because if you consider a divisor of, because n squared and n, they have a relationship. Do you agree when a divisor, for example, 1 to n squared? Do you agree when we... Oh, you got the answer with this calculation?
Yeah.
Okay, okay. Okay, wanna keep trying? Have you calculated completely?
Yeah. I think is it 391?
So let's check. 12391. Oh, yes, completely correct. Good job. You checked all of them, right?
Yeah.
Okay, we can also check to see it's 2 to the, let me copy. Let's see, can we calculate it also with Gauss idea? So, do you agree that if we consider a divisor, for example, 1, And then Gauss idea is n squared, okay? Then if we consider A and B such that AB is n squared, do you agree? One case we have that n, right? Except that if A is less than n, do you agree it is equivalent that what is greater than what?
Okay, is less than n. B is greater than n.
Exactly. So do you agree? We can consider this, and we should consider only these cases that says less than n, right?
Oh,
But it says they shouldn't divide n, right?
right.
If we consider they shouldn't divide n, what can we say from these halves? Suppose a divides n, right?
Mhm.
Means all factors. You can consider this. You can also consider this also to see can we find a better solution. But one way is consider casework like this, right?
Right.
Okay, in future we can also work on this to see can we solve it with Gauss idea, but with casework one useful way. So, have you solved 10 and 11?
Yes. Wait. My answer was I got for 10 y is negative 7x plus 28 over 5 and y is negative x minus 4.
Let's check.